So, welcome back to the DevOps track of the SFSCon. Now I'm going to introduce you Iustina Ivanova of University of Bolzano, PhD student, that will present us a project about climbing and software. So, Iustina, the stage is yours. Thank you for being here.
Thank you very much. Hello, everybody. My name is Iustina Ivanova. I'm currently independent researcher, and I present talk connected with Recommdender system for outdoor sport climbing. This is my presentation. First, I will introduce you with the topic of sport climbing. What is it? Then I will outline research goals which we found in this domain. Then I will discuss existing systems which in other sports related similar to climbing. Then I will discuss research problems and questions which we found. And then I will present the Recommdender system itself and introduce future plans. So what is sport climbing? Sport climbing is a challenging sport and it's very competitive sport. Here I'm using my personal pictures which we have taken with my friend in 2014 when we first time came to Italy for climbing. We were traveling, we were experiencing local culture, and we climbed different beautiful mountains. Here you can see also on the right-hand side the competition, which is held in Arco. Every year it gathers all the top performance climbers in Arco Stadium, and people compete, they climb. So, climbers would like to travel the world and they would like to visit beautiful places and they would like to climb beautiful mountains. And we came up with this research problem. There is a lack of decision support tools supporting climbers in their activities, such as training, climbing, finding suitable climbing routes and suitable climbing places. And for this purpose, we found two goals which we would like to address. First one is to enable climbers' activity detection for Recommdender system, and second is to propose personalized decision support systems for climbers. Then we started to look into other domains and into existing systems which have been developed for sport climbing. And in 2009, you can see that there was a system developed for climbers who would like to climb different climbing routes. This is the example of interface of such system, but the limitation of the system here is that climbers should manually insert their feedback about climbing routes they tried, they liked, and they are not profiled automatically. Then we started to look into hiking domain. Here I show two systems, one on the left-hand side, mobile app for hikers who would like to hike. And here hikers insert their preferences or characteristics of hiking paths and receive recommendations on the mobile application. On the right-hand side, I show the web-based interface for hikers to visit hiking places. And hikers are profiled manually via different type of questionnaires. The limitation here is, again, that hikers should insert their preferences manually and they are not profiled automatically. Then we looked into running. Here, the runners are profiled automatically based on the sensor data. This sensor data is coming from wrist-worn sensors, which are used during the training for marathon. And based on the statistics, based on data, profile of runners are built automatically. Based on this automatical profile, we can recommend training plans for runners. The limitation of the system is that people who do not use sensors will not receive the recommendations. And we decided to address all the limitations and to develop content-based climbing Recommdender system for climbers. Here we use feedback of climbers given as a logbook information. Basically, climbers use a website and they provide their feedback in terms of like, dislike, comments, and grades for climbing routes they climbed and for climbing places they visited. And we use this logbook data in order to profile climbers and to give them recommendations. Firstly, we give the recommendations in the web interface for climbing crags, and climbing crags are places which have approximately 10, 15, could be 100 climbing routes. And then we provide recommendations for climbing routes within the crag. So it's two-stage recommender system. Recommendations are given for three purposes: for motivational reason, for favorite moves, and for training. So this system was then developed as a prototype. For this purpose, we use approximately 130 climbing crags in Arco region, and we used approximately 700 climbers and their feedback, and developed a climbing recommender system and evaluated this system with first 35 participants who are outdoor sport climbers who at least climbed 1 year outdoor. And we evaluated according to system usability score, which shows whether the system is perceived as acceptable or not among the real users. The first evaluation was done with 35 participants, and the SUS score was approximately 72, which is, according to this SUS, is good, is perceived as a good system. And then we improved the system because there were bugs, and performed the second round of evaluation with 13 participants. Improved system achieved a SUS score of 90, which is excellent score, which means that users are actually interested in such kind of recommendation. Then we started to look into another problem, which is connected with outdoor sport climbing. Unfortunately, in outdoor sport climbing, there are many uncertainties. Rocks are falling, crags are restricted with the access, and weather sometimes destroyed the land. And in Italy, this problem is specifically important because here the landowners who actually have lands where crags are located, they sometimes close access to the crags. It happens because there is a law: if the climber visited the land where the crag is located and have some injuries, then the landowner is responsible for this injury, which is very strange law. And that's why landowners would like to protect themselves. They close access. We tried to model this environmental uncertainty. We called this problem is outdoor uncertainty. And we decided to model as climbers' visits prediction model. Here, the assumption is that if we predict how climbers visited crag or crags, then we can actually understand whether crag lost access or not. So for this purpose, we web scraped climbing crags features, and we understand first how climbers visit crags based on those features. So is there any reason why climbers visit crag? For instance, here on the x-axis, I show features of the crags, and on the y-axis, I show different users and their visits, correlation with features. And for instance, user number 2 has the highest correlation of visits with family-friendly feature, which means that this user is interested to visit crag family-friendly. So probably this user has kids, and for this user, it's more interesting to have recommendations for family-friendly crags. Then we applied different models to predict visits of climbers based on the features of the crags and based on their previous visits. Those models are basically solving a linear regression problem, and we applied polynomial regression models and linear regression model. And the baseline was the most popular model, which recommends based on the most popular crags. We can see that this problem can be actually solved with polynomial regression of 4 degrees, and the results are significantly better. Here we measure the top K recommended items, so we measure the quality of recommendations. That means that recommendations can be given according to the visits predicted by the features of the climbing crag. And we, after that, used the system which we developed for the new prototype. Here, we have different features and preferences of the user defined as the correlation for each feature of the crag. And then we predict for each user the possible visits based on these correlations and recommend crags based on the visits of this user. And if there is a new user who would like to receive recommendations, then we measure the most similar user who actually recorded ascents in our database. And in that way, we recommend only climbing crags which were visited by other people and not lost access before. This is what we've done after we took 85 climbers and asked them to evaluate 3 different systems. One is 27 Crags, which is the baseline, which is existing in this domain. And then we took 2 systems. One is content-based climbing recommender, which was developed by us, and visit and climb system, which addressing this uncertainty, outdoor uncertainty. We can see that our systems in every metrics, on x-axis I show every metric of recommender system, and we can see that our systems, 2 of our systems, outperforms the baseline, and moreover, the visit and climb outperforms significantly in such metrics as information sufficiency, transparency, overall satisfaction, and use intention. Then we evaluated according to the framework where we try to analyze why our system is perceived better. Here we compared our system, which is visit and climb, with baseline 27crags.com. And we can see that, for instance, system visit and climb gives higher level of transparency, which leads to higher level of use intention. And the system gives a higher level of recommendation accuracy, which gives higher level of perceived usefulness, overall satisfaction, and use intention. So this work is done for now. Then we also looked into image-based recommender system where the assumption is that climbers choose climbing crags based on images, and if climber chooses one image, we can recommend based on the similarity of images of other crags, similar crags. So on the left-hand side, I show the web interface, how user can choose the climbing crag. On the right-hand side, I show the top 5 recommended crags based on the similarity of climbing crags. Free software tools which we used are Flask, Python, PyCharm, which is free version, Jupyter, Leaflet, Seaborn, Scikit-learn, SurveyMonkey, Bootstrap, and JavaScript. And what are the next future steps? Future steps are connected with the training recommendations. Right now, there are companies who are working for sport climbing training recommendations, but they do not provide intelligent solution. They just simply generate solution on the go. So we would like to improve this algorithm. And that's it. Thank you very much for your attention. Is there any question? I'm happy to hear.
So thank you, Iustina, for the presentation.
Thank
and
you.
Now it's your turn. We have still 1 minute for a question, so someone wants to ask something. Otherwise, I do have a question.
Okay.
You said that for climbers, actually, you don't use sensor data. Are you planning to integrate sensor data in those kind of use case? And if yes, which one?
Okay, thank you very much for this question. Currently, I'm looking into wrist-worn sensors, which are provided by Kryptonite company. And those sensors provide statistics about how many moves climbers did and whether one hand is more moving than another hand. And they also measure the frequency of climbing routes they climb. So yes, to answer the question, I'm planning to implement sport climbing training recommendations based on the wrist-worn sensors.
Thank you.
Thank you, Stefano.
So, thank you, Iustina, another time for this nice presentation. We see us in 5 minutes for the next talk. And if you want to discuss this topic, you will find outside Iustina.
Thank you.
See you. Thank you.